You're going to chat about virtualization. Now, virtualization does come in several different formats, and this is why we kind of cover this. And we do kind of expand the definition of virtualization a little bit to allow us to cover a little bit more around the sides of it. So, as I say, we're going to cover the understanding of virtualization. We're going to have a look at configuring and managing some of these things. We don't go into an amazing amount of depth, but we go into the depth that is really required for both the CompTIA A+ exams, as well as getting you a decent job, shall we say. We'll have a little chat about some of the platforms that is used, look at some installations and how we can do things. So what is virtualization? Well, probably a good question I should probably ask in live chat now that you've all done the thumbs up that you can see it, is how many people have run a virtual system before? Use what we term as what you're going to get familiar with, a hypervisor. Thumbs up if you've ever used one before. Alan's done it before. Yeah, that's good. Where was that, Alan? Anywhere particular, or was it any particular virtualization hypervisor you were using? Just Alan that seems to have actually used a virtualizer machine before. Home and work, Hyper-V, VirtualBox. Yeah, there's lots of different ones out there. We'll basically have it. Alan, please feel free to chip in with your experiences throughout the course if you've used this before. Always happy to have people chipping in with the information and insight. So the real definition of virtualization, it refers to an abstract computer resources for the underlying physical hardware. Okay, we're literally talking about it is a fake machine that runs on a hypervisor or upon your hardware itself. And we'll go through the definitions, the difference between those two in a bit. So general architecture, so those images aren't big up, but general architecture for it is that you will run a software layer, essentially, which is known as a hypervisor, which tends to sit on top of the operating system. I say tends, I'm being a bit coy about it, because sometimes it does not sit on the software. Sometimes it sits directly on the hardware itself. And the benefits of it is, of course, that you are going to be doing resource sharing. Well, the idea is that you have a server that basically has lots and lots of resources in it, resource being a compute, so it's basically a processor with multi-threads, or memory, or disk space, or network connections, and it shares it out amongst a load of other virtual machines, and that means you can make the most utilization of it. So when you build up a virtual machine, think of it simply as another box that sits on your desk, but essentially it doesn't actually sit on your desk. It allows us to do things such as overcommitting. So for example, if I have a desktop machine that essentially has 16 gigs of RAM, and I want to run two virtual machines, I don't have to give them 8 each, making 16. I can simply go, actually, why don't I give them 12 each? Okay, both know that 2 12s are 24. All of a sudden, I've overcommitted to my resources. But you know, if you look at your task manager, which we all know how to find nowadays, certainly if you've been on this course, you should do, you will see that your memory utilization and your processor utilization and your network utilization is very rarely in the 100% mark, isn't it? It's normally running around 20 to 30, 40, depending on what you're doing, percents in there. So of course, hold on, we look at that and all of a sudden I've got another 60% that I'm not using. So all of a sudden I can give that allocation to someone else. So this is where we do overcommitting. You can also do something called scheduling, so you can give allocations and you can prioritize certain virtual machines within your system to prioritize those over the other devices. And this, of course, allows you to run mission critical items from on a virtual machine controlled by the hypervisor that then stomps all over the other ones that aren't so mission critical, and they have to go and sit in the corner while the main one that you've given all the prioritization to does all its hard work, which is mission critical. And then when it sits back, the others come back to life and they basically carry on with what they're doing. So there was a big significance of virtualization. It really evolved around what we were doing with our systems. Before virtualization, when I dream back in the old days, before virtualization, if you wanted to run an application on a server, say for example, if I wanted a DHCP server, we would physically go out and we'd buy a full box, full-blown server, we'd rack it up, and we go, oh, there you go, I'm running Windows on that. I am now basically going to run a DHCP on. And that's my DHCP server. Okay, and that meant I had to buy all the hardware. And then if I wanted to buy another server, I wanted to run another thing on a server that I couldn't run with DHCP, so it wasn't compatible, I then physically have to go and buy a brand new server. Okay, again, doubling the resources that I've basically had to spend out. So that's a massive benefit, is it can become a lot cheaper because I can now run both those systems on one layer of physical hardware, controlled by my hypervisor that will allocate resources as fairly as it seems. Any questions about that as a general idea? Okay, we're good. Now, one thing we can happily do with virtualization is we can mix and match operating systems. Because my hypervisor tends to be operating system neutral, they don't all of a sudden go, I'm running on a Windows machine, I'm a Windows hypervisor, you must only run Windows operating systems on there. No, there isn't that. The hypervisors go, that's great, I'm going to simply provide hardware allocation for anything you put on as a virtual machine. So I can run Windows with a Windows hypervisor, Hyper-V, and then simply install Linux boxes across the board, as many as I can get virtual machines on, that is. Okay, so we can do that, and we can basically mix and match. There's no reason on ESXi, which is another hypervisor that runs actually on the hardware end of things, I can run a mix of Windows and a mix of Linux systems on them. And indeed, I can put different flavors of Linux on there. So I can run Red Hat, Debian, Mint, and other ones that I fancy on that particular system. And the operating system won't even care, won't even know. The hypervisor handles it all and simply hands that over and manages all the hardware locations. Does also give us an additional piece of security because each individual virtual machine is essentially its own box. It has its own security. Hypervisor separates them. The two boxes do not connect to each other. Two virtual machines do not chat to each other. You can enable network communication through them, just as you can enable networks between two servers that sit next to each other. You plug a network cable in between them and they can talk through networks, but they cannot communicate at the operating system level. And it's exactly the same with virtual machines, in that those two virtual machines will sit totally separate. They will not be able to communicate with each other. They will not be able to use each other's disk drives or other hardware resources. But if you do want to plug essentially a virtual network connection between them, yes, you can happily do that on your hypervisor and say they can now communicate on their network level, just as they would if you plug their cable between. Everyone got a good grasp of that essential complex? I'll think of the right word there. That idea, we'll call it an idea because I can't think of the long posh word for it. Give me a second to reply while I have a tea. Another big benefit is it enables a dynamic scaling of the resources. And we're going to talk about that in a little bit of time. Paul, I can see you typing a question. That's fantastic. I'll type in a comment anyway. Okay, so we're going to cover a lot of these details as we move through the slides. So as a summary, Paul, good to see you about to say you understood. So as a bit of a summary then, so virtual machine uses the physical resources that are on a host on a computer, while the physical machines have dedicated hardware resources. Virtual machines share the resource of one computer, so they play nicely together essentially, and it's possible to be a bit more flexible with the physical memory and other items that are on the system. And the virtual machines can operate on one physical host through virtualization, while physical machines essentially run one operating system. We're going to tell you that's a lie later on, but that's what we're going to stick with at the moment, okay? We'll go into the reasons for that as we go through. As you see, physical machines, they have certain restrictions. They require a full installation. VMs can be quickly created, copied, restored from files, and do not require a full OS to install them. We'll talk about those in a bit. Physical machines hardware must be upgraded. Okay, we've gone through this a little bit before. If I want to upgrade increase the amount of memory on my machine, how do I actually do that? There's an open question on anyone. What do I need if I want to increase the actual memory on my machine? Say, for example, I'm running 8 gigs and I want to go to 16. Then I know what the first thing I need to do is. And then we can kind of go on from there. It's a general question, so any answers are good. Mardy basically smashes it there. You have to install more memory. So what? I have to go and get some memory. I have to purchase some memory, the hardware. Purchase my bit of hardware. I then have to turn my machine off. I then have to plug this in. And then have to turn it back on again once I've taken the case on and off, etc. Okay, that's quite a long-winded process. With the virtual machine, if the memory is available on the hardware, if I give my virtual machine 8 gigs of memory to start with, and I want to go, oh, that's running a bit slow, I need 16, I just go to a little tweak and I just turn the dial up and go, bang, there you go, you've got 16 now. So I go to the hypervisor and I simply say, okay, that machine's running with 8, please give it 16 now. Some hypervisors are smart enough to do this dynamically. Some will insist you shut the machine down and restart, and sometimes the operating system that's running on those systems may get a little bit funky if you just go, oh, by the way, you've got 16 now. Some operating systems might go, are you sure? Hold on. And you'll have to restart them, shut them down and restart them. But generally, it is done really quickly and really simply on those systems. And it's good for partitioning. So we can basically separate systems up. I can spin up test machines. Bang! I can spin up test machines left, right, and center as much as I like. Play with different environments, tweak different settings on it, and then basically make sure we do things in there. Seth, thank you very much. Alan, Mardy, good to have your questions in there, your comments in there. Really spot on. So there's 4 key goals in IT. Generally, virtualization helps these 4 particular key goals. And just as I go through that, my slide presentation drops out on me. I'm blaming the weather for this. It's what always happens when you get sunny weather, isn't it? Let's kick us back on here. So 4 key goals. So within the 4 key goals that we have then, number 1, which is key for everyone's mind, is going to be cost saving. How does virtualization save us cost? Okay, we straight away reduces the number of physical servers and hardware resources that I need. Because remember we said we're going to be sharing the resources. So instead of having to run 2 physical machines with 16 gigs each, I can run 1 physical machine with 16 gigs, and I can share that on 2 virtual machines. And we can simply run it like that. That gives us more flexibility. We love flexibility in IT because we like dynamically changing things. Someone comes in with brand new ideas. We love to change things. VM gives us a lot of flexibility because we can spin them up and turn them down. We can do what we like with them. We can scale them to increase them, and we can dynamically change the size of those virtual machines. We can have several running as backup, and it also means with the flexibility to be a bit more upwardly mobile. If I'm not having fun with a virtualization environment with a particular server, I can copy that virtual machine and I can stick it onto a brand new server. Well, I repair that server, possibly to add some more memory on it, possibly do something. That VM can carry on running. And you will note that there are actually hypervisors and things such as vSphere, which basically manages other hypervisors. It's a management system that manages hypervisors that will allow you to dynamically move that virtual machine, so you don't even see any downtime. For example, if it's your web front page, it's critical for people to basically get access to. vSphere will allow you simply to shuffle it across to a new server, new physical server, and you will see no downtime from that at all. You simply go, okay, we're going to spin this one up when it's ready. We'll now redirect all the calls to the new system, and you can shut down the old one. So you can see straight away, maintenance now doesn't have issues with us now. We can carry on running our key applications, our key SaaS services and PaaS services while we're shuffling things around, while we're repairing, and even while we're moving. So you can kind of talk about picking up servers and moving different locations with these. And this is a beauty of virtual machines, isn't it? And then another really important one is our time saving. We know for a while that time is money. Time saving virtualization means you can quickly create them. Reinstalling operating systems is very simple and very quick on virtual machines. Spinning them up and down is really quick. Physically booting a server, you have to go through pre-operating system test, which is the post stuff. You have to load BIOS or the UEFI, depending on which one you're running. You have to do a variety of hardware checks, load the stuff off of the disk, and up you go. With a virtualization environment, well, we can skip half of those checks, I've basically said, because the hardware is already up and running. Everything's all good. All we've got to do is spin up that software. Bang, off we go. So it is very time saving. And last but not least, we have resilience. Okay, the resilience allows us to dynamically move the virtual machines around. Okay, so it's going to simplify things such as our redundancy. So if I know that I've got potential problems with the server, yeah, of course I can transfer VMs elsewhere. I can have backup VMs just sitting there waiting to be spun up if I notice any particular problems. And we can expand the workload. So we can do what's known as horizontal scaling, which is where we add more and more virtual machines to make it horizontally scaled. And we can happily do that. So again, our workload can be moved, manipulated, and indeed optimized, which gives us the resilience that potentially we'd need. Any questions about those 4 IT goals? Those are critical IT goals. And every time you mention those in meetings and things like that, people will perk up and go, you must know what you're talking about if you're talking about money, flexibility, saving time, or resilience. Good stuff. Okay. Virtualization benefits. Bit of a summary? Yes. Okay. Server consolidation. We know full well we are no longer going to have to run 400 servers for our virtual environment or less. Okay. Even a couple of servers. We use a lot of virtualization in the cloud environments. Okay. If anyone's basically used any of the cloud environments, that's all driven by virtualization. Okay. They're not physically going out and turning a new machine on in a data center when you go, I want to run up, a version of Linux or something. They are simply providing you with a virtual environment for you to play with. You can run multiple operating systems. Okay, we don't have to worry about whether or not the operating systems are compatible with each other. So we can run Windows, we can run Linux environments in there. And we know they are great for disaster recovery. Because one thing we can definitely do, if we've got these items backed up somewhere, or if we've got another data center that we're twinned with, virtual machines means that if they're copied and they're simply sat dormant in one location, if my primary location, God forbid, goes up in smoke, then all I've got to do is turn on the ones that are at my disaster recovery center. I simply flick a switch and off you go. It's not even flicking the switch with the virtual machine. I flick my virtual switch. Sandbox and testing. You will notice that a lot of companies that are very keen on the antivirus land will run virtual machines because they can very happily separate those. I mean, it can stop the viruses from spreading. But as I said, basically making sure there is no physical network connection, or not physical, no virtual network connection to the rest of the world. So they can take a virtual environment that has been infected, they can simply put it on a new system, clean system, in a new hypervisor, and simply test it to pieces while still having access to everything else. So it's great for sandboxing and testing things. And there's some legacy support. We know for a while, I mean, I will constantly go on about accountancy software. Accountancy software is if you ever get an IT manager's position, the one thing you will hate is accountancy software because they are so sluggish to update accountancy software that it always seems to run on about 8 versions of the operating system old. Okay, I remember basically working with a certain company that used to only support their accountancy software on NT products. So we're talking old server products here. So of course with virtualization, if I bought a brand new system wanting to upgrade the machine, nowhere could I basically install one of those old operating systems on it. So you simply install a nice, clean, beautiful system, you run a hypervisor, and then you simply dump that operating system into that hypervisor. An old legacy system will actually run, so I could run NT systems, NT servers to keep my accountancy software running, which was fantastic. You can move from a physical machine, so there are products out there that will simply take a snapshot of your server system, and it will go, right, you want to convert that into a virtual machine. It'll take a full copy of that disk, create a virtual machine out of it, and then you dump it wherever you like on any of your virtual environments, any of your hypervisor environments. You can go the other way, but you kind of ask yourself, why would you go the other way? So you can take a virtual machine and you can dump it physically onto the hardware, so it's vanilla. Now, there's one thing that I haven't kind of mentioned. I kind of give you all the benefits, don't I? We sell virtual machines, lots of benefits, lots of great stuff. This is where we want to be. Okay, there is one very minor downside with virtualization, and it is, I'll be honest, it is a minor downside. Because you put a operating system onto the main kit, then you put a hypervisor, and then you put your new operating system on. There's obviously a bit of thunking that goes on, a little bit of time that happens as it basically feeds through that environment. It's in no way anything that we would notice. And the benefits far outweigh any of those particular costs. I've got any questions about the concepts of virtualization before we kind of have a little look at the different types of virtualization that you can have? Because there is different types. And this is all to do with the way the hypervisors behave and the resources are behaving. So I get a thumbs up from everyone who thinks they understand virtualization as a concept. Sebastian's fastest fingers in there. Well done, Sebastian. Of course, questions, we love questions, so please do throw them in. Maximilian, Luca, Paul Bird, beautiful. See we're coming through. Ronell, well done, Ronell. Zachariah, Khalifa. Sorry, Marty, Chris. Here we go then. Okay, that's smashing. That's good news. Okay, so let's have a look at the types of virtualization, because it's true to say that not everything is the same on the box. So let's have a look at hardware level virtualization. This is where the hypervisor runs directly on the hardware without an operating system. I kind of wish we did this the other way around and we talked to it the other way. But let's have a little look at what that looks like. So this is just the concepts, Ronald. We'll get to the rest later. We'll try not to confuse you. Don't worry, we're good with these things. So you can imagine it now. What you basically have is you have your hardware. You have your server hardware level. And then on top of that, you run what's known as a hypervisor. Now, the hypervisor is the tricky name for whatever it is that manages your virtual levels and allocates the hardware resources. So you can see at the bottom here, we've got the physical hardware, CPU, memory, storage. We then, instead of installing a full operating system, we install a hypervisor. So when you finish your boot process and the UEFI or the BIOS hands over to an operating system, that operating system is actually the hypervisor. And that operating system will manage all those physical resources for everything else. And as you can see here, we are running we're running 4 virtual machines on there. Well, with VM to N is basically as big as it gets, isn't it? And each one of those systems separately will have their own operating system, will have their own apps on there, bins and libraries. Bins and libs basically means it's basically working for our Linux system. Okay, so we have got 4 separate systems there running on one physical piece of hardware controlled by the hypervisor. So all the communication that happens between each individual virtual machine and the hardware, because of course it needs to access the hardware, it needs to access processor, memory, disk drive, and networking resources, will be channeled through the hypervisor. So essentially your hypervisor is juggling the resources between 4 or X number of virtual machines. Okay, so that is normally commonly known as hardware level virtualization. Then the second one is OS level virtualization, which means the hypervisor actually runs on top of an existing operating system. Okay, so we've already basically got our machine up and running. We've got a Windows 2025 server. We've done the installation of Windows 2025. And as we know, the 2025 standard, I believe I'm right in saying this will allow you to run 2 virtual machines. If you run data center, you then just pay extra licenses and run more and more virtual machines on that system. So we run the operating system. So we have hardware, operating system, then we run the hypervisor. So there's a virtualization layer there that is our hypervisor. And that's the one that basically deals with all the conversations between our operating systems, our new operating systems that we've installed, and the Windows operating system. So it doesn't, the hypervisor at this stage does not talk directly to the operating system. Does that sound good for everyone? Good. And then the third and final application level virtualization. Now, we've all probably run this. When I say we all run this, most of us have run something similar to this, I thought. So application level hypervisor is where I run an operating system. And on that operating system, I will run an application that will manage what will be my hypervisor. Now, classic examples of this are things such as Oracle VirtualBox. Oh, let's have a little peek. We've got a couple of minutes. We've got a couple of minutes. Oh, I wish I hadn't deleted a couple of my servers now. Oracle VirtualBox. How many people have used Oracle VirtualBox before? Thumbs up. I know one of you has. Probably just going to be the one, isn't it? From the earlier questions that we answered. So this here is Oracle VirtualBox. It's a piece of software, just like Microsoft Word or Excel. I've downloaded it off the internet. I've installed it on there. When I run it up, yeah, Khalif, Ronel, Khalif and Sebastian's basically use it. So you can see here, I've got a hypervisor here that's running as a piece of software, as an application, and I can install a variety of different operating systems. I've got Red Hat 9. I've got something called Disk Manager, which I think is a Windows one. A couple of other Windows 1, Ubuntu, and DBAN systems on there. So those are literally running at the moment. I've got one that's actually running. You can see what state it's in here. And indeed, that itself would appear as, I know I'm going to drag this across, but I know it's going to appear massive on the screen, so we're going to try anyway. Oh, no, it's good. So that is my machine running. That is my virtualization environment running on my own little system. Wow, let's see if I can remember the password. Boom, look at that. There you go. So I'm literally running that third example that we showed you, which is the application level VM. So I can spin up 2, 3, 4 virtualization systems with different operating systems on my machine, and I can tinker as I like. It doesn't affect it. I do not need to worry about the hypervisor because that's basically running in there as well. Any questions about that? If I do keep muting the microphone every now and again, I seem to have developed just a little bit of a tickle in the back of my throat, so I may be coughing a little bit. Ronel, does that help and make that a little bit clearer for you, what I've just shown you, in terms of how the hypervisor and everything else runs? Good, that's beautiful. Right, I'm going to drag these off the side. We might well come back to those and have a little tinker later. That's if they're running. My poor old laptop will be struggling if I run too many of these. When I said obviously my laptop's struggling, of course, I'm running that application, which is a hypervisor. That application itself is using resources on my machine. And this is what I mean by the fact that, the vanilla environment will get you the best performance ever. So if I just run an operating system on the hardware, that's going to be the optimal performance. But because I can run several different virtualized machines on a hypervisor, that hypervisor will be using its own resources. It will be using its own processor power from your server. It will be using some memory from your machine. Does VM count as virtualization? VM basically is one of those beautiful acronyms that is virtual machine. So the virtualization that we use with Codio is a virtual machine because Codio doesn't have one server for each of you. Codio basically is a big box. I'm exaggerating because I haven't actually been to the data center. It's a big box they've got there that sits there with loads of memory, loads of processing power. And when you log on it through essentially what is a software as a service environment, and say, for example, Mardi logs on, it goes, right, I'm just going to spin up that virtual machine for Mardi. Bang, there's one machine. And then Ronald logs on. Oh, and it goes, hold on, I'm just going to spin up Ronald's virtual machine. Yeah, and then Alan, Sebastian, Khalifa, etc. And then we just get loads and loads. So there could be 20, 30, 40 virtual machines that are running there. That's all the virtual machines that are offered by, well, they're virtual machines that are offered by Codio. And we know that every time you log on to that virtual machine, you're going to get exactly the same thing. So Mardi, you're going to start off with exactly the same operating system configuration as Ronald does, because it's a disk that we've created, a virtual machine we've created, we've duplicated it, and up it goes. You've got exactly the same environment. So there is no, you need to configure this, you need to configure that. So that's what Codio is basically doing in virtualization by providing those virtual machines for you. They are actual virtual machines running on a hypervisor, aren't they? That clear that for you, Marty? Great stuff. Okay, so we can see here, basically, there's a bit of slightly better graphics here in terms of when we talk about the virtualization. We have full virtualization, partial virtualization, and hardware-assisted virtualizations. Okay, and you can see the applications are on the left-hand side where our hypervisor, which is our VMM, is basically communicating in general with the host system. Okay, and the guest OS will basically talk to the VMM and then on to the system. So that's what we call as a normal full virtualizations. So any normal requests that need to go through to the CPU or to anything else needs basically to hit a guest OS, normally through a virtual machine. Now, the difference between that and the para virtualization is the guest OS can be modified to be aware of the fact it is running on a virtualization machine. Okay, so this is for example, a Linux machine. You can get certain versions of Linux that are designed and know they are going to be running on a virtual machine. So that, of course, takes out a little bit of the hypervisor layer, because now our hypervisor doesn't need to be so complex, doesn't need to be so aware. So we've got a thinner hypervisor virtualization layer, and the guest OS knows about it. So it knows to make the calls in the right way. So they work hand in glove. And then there's the hardware assist, where the hardware is also made aware that it is basically going to be doing virtualization. So it sort of leverages the CPU extensions like Intel VTX, I think is one, to improve the performance for full virtualization. Okay, so the hardware knows I'm going to be run as a virtual machine. I'm going to handle virtual machines. So they leverage additional details that you can basically customize on these sort of things to give you that extra speed, that extra little tweak of benefits on there. And indeed, I believe Amazon and their data centers run their own hardware nowadays, and they run specific processors that know this system is going to be a virtualization environment. So they perform better than the Intel or the AMD processors would do managing a virtualization environment. So that's sort of hardware optimization or stroke assist. Any questions about that? This is literally how we kind of improve things in our virtualization environments. Good stuff. So user cases. So we will basically use full virtualization is used when you can run a complete guest OS. Okay, the benefit, one of the big benefits of that is basically that we can run any OS. We don't need to install our hypervisor that is specific to the operating systems we're going to be running. Okay, so if I run a full virtualization environment, as I said, I can put any operating system I like on. Now, when we talk about para-virtualization, and we're customizing the guest OS must be modified to work in tandem with the hypervisor. So my guest OS, if I'm running Hyper-V, my Hyper-V must know the guest OS I'm running, and the guest OS must know that it's going to be running Hyper-V. I can't then pick up that guest OS that's customized for Hyper-V and run it on ESXi, because it will simply go, hold on, I'm not talking the right language anymore. So we're not on the same operating system I'm expecting to see. So you lose the portability of it. Any questions around that? Oh, let's have a look. Cisco has virtualized routers on specific hardware. Yes, we can go into virtualized networking. Did we mention that when we talked about advanced networking? I think we did. Didn't we do software-defined networking? As well as hardware-defined virtualized routers on specific hardware. Yes, that's definitely the case. Good spot, Alan. And depending on what you want to run, we talk about doing this for virtualization, didn't we? But there's also Cisco Packet Tracer as a good example where we we run virtual network scenarios, can't we? And we can run virtual network scenarios, and then we can pretend we're running different routers, different systems without spending thousands of pounds and dragging them out and installing the hardware, running the cables. Good spot, Alan. Well done. Very good to bring that in. So it's all kind of brings into our resource management. So resources, we will go through this. The resources basically that we are handling out are things like the CPU time. Now we know that technologies are out there, such as I mentioned the VTX, which provides hardware acceleration for virtualizations. But generally, if we run an operating system on it, we can run virtualization. We are chunking up the hardware resources and giving it out. So we are handing out CPU when you configure this, memory, networking, and our storage space. Now those tend to be the four allocations, the four things you're worried about when running virtualization. Okay, and all the rest kind of gets tacked onto the side of those things. So just as a quick refresh, we know the CPU, GPUs, and other things like that are really the central processing unit. That's the brains of the system that does the hard work. We know the memory controls our random access memory. So this is the fast memory access that we have. Excuse me. That has a temporary store for details, code, data. And then we have our network utilization. So although we potentially may on a server have 4, 5 different network cards, NICs essentially in the back, that we can plug network cables into, when we drop onto our hypervisor, excuse me, each one of those machines can be given multiple network interface cards. We don't have to stick to the numbers that we've got. Ubuntu PC settings, and I'm using this just as an example, okay? This is the sort of thing we end up doing. You see here, I've got a bridged adapter here. So I've got adapter number 1. Hold on, I've only got one physical adapter in my machine. So I can get another one. I can basically put that in as a NAT. Right, and I can put another one in as basically being a, let's have a generic driver on that one. And let's have a host-only network adapter. So now if I boot that machine up, that virtual machine, my virtual machine thinks, oh God, I've got 4 network cards. So you can see how virtualization is fantastic because I can lie to the systems. I can fake to the systems that they've basically got more network resources than needed. And the hypervisor will basically manage all that system. This does mean that if you're running something like ESXi, for example, when you run ESXi, not only do you consider your virtual machines in there, so you can build your own virtual machine areas, but you also can create network switches. You can create routers in ESXi, and you can have your whole virtual environment mapped out just as you would have done in a network server room by plugging a few switches, a few routers in. Right, you map that out in a virtual environment, ESXi being the hypervisor, and you can go, hold on, I want to connect server A to server B via that switch. And you simply just drag lines, add the connections, make your own virtual LAN in there, and then see how they perform. So you can test things, you can play with things before you go to the real world and kind of go, here's my switch now, I've got the configuration that I tested in my virtual environment. So they are great fun for that sort of thing. So that is my network allocation. And then there's storage. Yes, now there's obviously storage can be used in a variety of different ways. As soon as you step into, excuse me, as soon as you step into something like a data center, and we start dealing with servers, we know we have things which is our direct access storage, which is storage physically on the server. Remember, I lifted up that massive server and showed you some disks. So that's physically attached storage. But then there's storage that is essentially a NAS or SAN that is offline. Well, it's not offline. A NAS or SAN that is not physically attached, is connected via the network cable. So it talks to it as a network resource. So we can allocate those as well. So it means that we do not have to worry so much about where our locations are. And yes, although that is elsewhere, physically elsewhere, our hypervisor, ESXi here, still knows about it. And it still knows it's got an allocation over there in that little box in the corner. And it can chunk that up and then it can fake to the systems. Yeah, it can say, well, you've got C drive and I'm now giving you a D drive with this much space. And I'm going to give you a RAID configuration, etc., etc. So we know we can basically tell these systems, get these systems configuring and working as we want them to be. Although the resources isn't necessarily, or the storage isn't necessarily physically on that server that we are connected to. Great fun. Excuse me. Let me have a little sip of my coffee and see if it clears up a bit. So have you got any questions? Think of some questions while I'm basically having a quick sip. Okay, so one big consideration that you basically have, although we can tweak it, is how do I decide what VMs to run where? So if I've got four servers, 4 big chunky servers, and I've got 18 virtual machines that I'm going to run on those servers, how do I know which ones to put with which box? We've got to consider the profile of that virtual machine. What is that virtual machine designed to do? What are the peak demands? Alan says virtualization is not very good with video resource sharing. Ones with the GPUs, a lot of servers now have massive GPUs in them, so they can do very well, but potentially you're throwing stuff down the network, so potentially it's not great. So peak demand. So you've got to consider these things when you're considering which virtual machine to run on the same box with other virtual machines, so they play nicely together. You've got to consider things such as your peak demand. Is it going to be this is a backup server, virtual server, that all of a sudden at midnight is going to want to use all the disk space activity and all the network activity for that machine, and therefore chop everything else? You've got to think about workload considerations. Is it a case that I'm running a SQL Server database that is going to be memory hungry? Well, I probably don't want to put that with someone's graphical environment that they're basically running the main graphical database with, because then we're going to clash over the memory and everyone's going to be memory hungry. Memory intensive workload, as I basically said, and network loads. So we've got to think about those particular things when we basically decide which virtual machine to tag up with a different virtual machine on that physical piece of hardware. Now that sounds really hard, doesn't it? That sounds really a nightmare and things to do, because you might struggle to get that right the first time. But that's okay, because they're virtual machines. We can simply just lift and shift them onto different boxes if it doesn't work. And not only that, you have tools that will help us to do these things. So we can have hypervisor monitoring, which will tell us, it can monitor our hypervisor network across our data center, which will tell us how the hypervisors are performing, which hypervisor, which physical server is getting spanked on the memory, which operating system, which one of our virtual machines is causing those problems, which one is high, which one is low. And we can monitor those, and we can very simply juggle them about to make that a nice even playing field across our board, because that's really where our target is, isn't it? Is to get a nice even playing field across the board. So hypervisor monitoring. Any questions about the hypervisor monitoring, what we do? There's a multitude of hypervisor monitoring tools out there. I kind of mentioned ESXi, and ESXi is the main. I'm trying to remember the name of the funny one I use. vSphere. vSphere is quite a nice one that's basically used for some of these things. So as I say, best VM performance monitoring tools. This is just a quick snapshot we took. Of course, this may be out of date because it's probably more than 6 months old. So you're going to take into considerations the hypervisor monitoring can be performed using a variety of tools and methods. And indeed, years to come, AI is going to come into this as well and help us monitoring those. It's going to make suggestions about things. There are native tools provided by essentially hypervisor vendors, such as VMware vCenter, Microsoft Hyper-V Manager, and the Citrix Zen Center. And there's a lot of third-party wins. SolarWinds basically do virtualization, well, dropping off the networks, isn't it? SolarWinds Virtualization Manager, Nagios XI, and Zabbix, I think they pronounce it, depending on if you come from America or not. It gives us a different number of tools. And there are simply some agent-based ones, such as Datadog, Splunk, AWS CloudWatch. These are all kind of agent-based ones that will help them out. When you look at these virtualization tools, it's important that you think about hypervisor monitoring. I think we'll go through this slide and then we're going to have a little break. So I can have another sip of water and get rid of my cough. You got to think about the resource allocation. So you've got to consider hypervisor monitoring, what tools you're going to use, how you're going to manage your resources, so resource allocations. Performance monitoring, because we want to make sure that the systems do run to the best of their performance. Do we need to put more memory into a physical box so we can allocate that onto the other machines? We've got load testing tools. It's great basically to have a theory, but you know full well in IT, when you have an idea, you want to make sure that idea is great. So what you can do with virtualization, before you go to your live date, you can load test it. If you know this is going to be, for example, a customer front-facing web portal, and you know this is where you're going to get all your orders, and you happen to be booking Elton John at one of the massive stadiums, you know full well as soon as you flick that switch and make it available to the public, you're going to get shed loads of requests. How do you know your system is going to cope with it? Well, we can do load testing. We can simply use some load testing tools, and we can fake that massive rush that everyone's going to be for booking Elton John tickets. And we can see how it performs. So we can do load testing. So we know it's going to work when we turn it on. There are some good virtualization practices that we'll go through. Profile workload. We need to allocate profiles to our particular workloads. So we know what we are going to expect with, say, for example, a particular SQL database, you know, how many trillions of data writes that's going to need, and compare that with, for example, like Alan says, a video resource system that's basically doing it. We can allocate reservations and limits. When we say to our hypervisor, oh, here we go. When we go to our hypervisor, in our settings, and I allocate a disk drive, a storage, have I got one there? Empty controller ID card. Yeah, so I allocate a storage. I've given this a virtual size of 52 gigs. Actually, only using 8. So strangely enough, we're not writing a 52 gig file out, sorry, a 25 gig file out. We're only writing an 8 gig file out, but it will dynamically adjust. Now I can go, this is my main system. I always want to make sure it's got exactly the right amount of space. So this one's dynamically allocated. I can change that when I basically set up my virtualization machine, and I can say it will always have 25 gigs, and it will write 25 gigs. It will go, that's my block, that's on the disk drive, that's sacred and that's secure. So no matter what the other ones that might be a bit naughty and expand onto the disk drive, they will never overwrite that 25 gigs I've allocated in. So we have the option to basically make it fixed, or we make the allocation dynamic. We talked about distributing workloads to make sure we aren't hammering one particular server when the others are sat there with their feet up on the desk. And we know we can shut down and consolidate VMs. Remember we talked about the horizontal expansion of virtual machines, basically just adding another and another virtual machine on the end when we talked about it. Yes, we can shut down and consolidate virtual machines that we don't want. It saves what's known as server sprawl, which is where you just buy one server, you allocate it to something, you leave it there, and then you get another and another and another. So you've got 10, 15, 20 servers. You haven't touched that one because it's not working, you don't need it anymore. No one comes and decommissions it, because that's a heavy task, isn't it? That's a hard work, getting someone out there decommission that server. With virtual machines, we can simply go, well, that one hasn't been used for 25 days, I'm just going to turn it off. Click. And off you go. So it is simpler and easier to manage and prevents what's known as a server sprawl. Good. I think we're probably going to break for a 10-minute break if we can, please. I'll give a 10-minute break for you all to get a comfort break, an apple, a pear, banana. I'm going to go and get a glass of water. And we'll see how it goes. We will speak to you in 10 minutes. Welcome back, everyone. Well, I hope you had a chance to have a little comfort break, have an apple or banana. Now, I've got some orange juice to try to stop the tickly throat that I've got. See how that goes. Mardi, installing Linux, Ubuntu on an Oracle VirtualBox. See how it goes. I mean, this is the whole idea with these things is you try it. If you play with these things like VirtualBox and other things, get used to the virtualization, you can try different operating systems. You can try different environments. You can try different hypervisors to see which one works best for you. Okay, so back in the room then. Security and maintenance. Let's see a thumbs up for everyone who can see security and maintenance. All birds in there, Marty, precious. That's great stuff, Peter. Lucas, I've got the whipping through. Hablan, Josephine, Ronald, Chris, Ethan. Well, thank you very much. Let's get on with the show. So we know we have had a quick discussion about virtual machines. Let's talk about security. Secure virtual machines, they are machines. Let's not go out on the limb here and basically go, because I'm running in a virtual environment and my host operating system has got a endpoint protection on it. I need to forget about the virtual machines. No, do not do that. Okay, your host environment and indeed your hypervisor is not in charge of that. Essentially, that endpoint's antivirus system. Okay. We know there's going to be attacks on these systems, so we know we basically need to look at a holistic approach. We need to basically allocate and give our hypervisors and our virtual machines the ability to protect themselves. We know we have to secure them. We know that there can be a bit of virtual machine sprawl happening as well, because they are so easy to spin up and get running. They're also really easy to forget about. So if you're not monitoring them and you're not keeping in constant touch with these systems, it's possible one or two may come up. When you know there's one or two coming up and basically being used on the edge cases of your vision, for want of a better word, it's possible those one or two are now not running the latest operating system. They have not had security patches applied to them, and that in themselves makes them vulnerable. So they will appear in your vulnerability scans if you happen to run. They appear when you do pen testing. But if you're not doing those things, that machine can be sat there in a vulnerable state for a certain number of days before something basically happens to it. So we've got to make sure that we look after those systems. It's important as well, things such as your hypervisor is running its updates, making sure the hypervisor gets update. And we prefer to think of it in a hardened state. Okay, you've got to keep it updated and guarded, because of course the last thing you want is a virus that has been specifically written to target a particular hypervisor and will therefore then go around and encrypt a whole load of your virtual machines, and they will not be able to boot up and they will not be able to do it. Remember, they are not attacking the actual virtual machine. That could be very tight and secure, but the hypervisor gets infected. The hypervisor controls the disks that they're running. Okay, and therefore we could get encrypted virtual machines, and then you lose the whole virtual machine in terms of its environment. So make sure you pay attention to things that are going on in there and keep those safe and secure, just like you would any other operating system stroke machine. So we said a couple of best practices. Harden the hypervisor. Strict limits and privileges. Make sure that people that are accessing it have strict limits and privileges as well. So you allocate maintenance and you allocate administration to it. Leverage antivirus protection. Yes, you can now actually buy antivirus for your hypervisor. So not just for your operating system, you can get a hypervisor intelligent antivirus system, as well as an operating system antivirus. Restrict communication between virtual machines. We know full well that viruses basically propagate by getting onto one box, and then they'll spread out amongst all the other machines you've got. It happens exactly the same with virtual machines. So although it's easy and you're not running an additional cable to give them extra access, do they need that extra access? Ask yourself that. Can I harden the ports? Can I do port blocking? Do I need to have a virtual firewall in there as well? And configure the firewalls in those systems. And do several things like implementing virtual machine backup policies. So with isolations, offline backups to aid recovery from ransomware. We'll talk about backups later on. We've got a lecture on it. There's a 3-2-1-1 rule that tends to be bandied around a bit, and I mention it here. It applies exactly the same for virtual machines as it does for your physical data. Okay, we're going to the 3-2-1-1 when we talk about backups rather than here. Not that exciting, don't worry, you're not missing anything. So we know we've got to back up virtual machines and we've got to look after those systems. General maintenance, as I've said, they will all need patching just as you would with a real physical machine. Look for guest OS updates, hypervisor updates, firmware updates. Firmware updates are on your physical hardware that's running these hypervisors. Consider the backup and disaster recovery. What happens if the systems go down? What do I have all the relevant latest snapshots of my virtual machines in the right location? So if my main office goes up in smoke, I know where I can get hold of them and I can spin them up. The benefit and the real beauty of a virtualization environment is it is really easy to test because you don't need to run it onto a live system. You can simply run it in a smaller environment and just check that they all come up as expected. You're not going to give it a full hammering and not a daily usage hammering. You're just going to run it up, make sure it works, make sure the applications on that machine work okay, and then you can close it all down. So it's not a big as hassle as it used to be. In the old days, the only real way we physically would properly test our backup and disaster recovery was very simply to drive over to the location that was our disaster recovery site, turn all the power on, basically run up all the servers, and then check all the configuration and everything came back to life properly. Okay, we can do that in a virtual environment nowadays and make sure everything's good. So we'd no longer physically have to drive out places. Do keep your security and scanning audits. We basically said about our pen testing and our vulnerability scanning still applies in our virtual environments and configuration management. All right, put your hand up if you're ready for a Kahoot session. I can see a few of you on Kahoot there. We will repost that link so a few of you can get back up in there. Okay, great stuff. Right, if you're still joining, shout now. I'm going to run the Kahoot session. Who remembers who won last week? If Ronald's typing and it's him, I should start the session so he's distracted. No, okay. Let's have a little look through this then. Ready? Steady? Fingers ready. A puzzle one. Put this stack in the right order with hardware at the bottom. Team 14, have you got to the answer already? Let's see if we can get the last couple through. Look at that. 13, you got it right. Well, I am impressed. This is good. If you got it right, pat yourself on the back and have a virtual suite. We always run, not always, hardware at the bottom. Then there's normally a hypervisor and then a VM operating system, so the virtual machine operating system, and then the application on top of that. I was a little bit sneaky there, and it's possible that some of you that might have got it wrong might have thought the VM operating system was the operating system on the physical machine and might have put those the other way around. Put your hand up if you put those the other way around. So if you went hardware, VM operating system, hypervisor, and application, show me a hand if you did it that way around. Peter, Sebastian, I will. For me being a little bit tricksy over that one, I will happily send you a virtual suite, people. See how that affects the score results. Ithasham, basically at the top. Well done. Paul B, Max, Zachariah, and Joking in there. Okay. Virtual points, that's what you get in a virtual environment. See about the next question then. Overcommitment in VM is, what is overcommitment? Seven got it spot on. 8 fell into the sneaky trap. The VM taking more resources than the host has could well be a decent answer, but it's actually the hypervisor assigning more hardware resources than the VM than actually the host has. Good if you got that one right. Max has jumped up a bit. Marty, Eddie is basically in there as well. Good, well done, everyone. Virtualization allows multiple virtual machines to run on a single physical server, optimizing hardware and utilization. True or false? See, that shot right up that number, didn't it? People who had answered. Well done. $16, that answer is true. It is definitely allowing virtual machines to run on physical hardware. Max was on fire. Beautiful. Let's have a look at the next question then. Physical machines can be provisioned faster. So physical machines can be provisioned faster than virtual installations. Let's see how many of you blow this by going for the fastest fingers and accidentally click the wrong answer. You may confess it in the chat window. 12 of you got it right. Physical machines can't be provisioned faster than virtual machines. Imagine provisioning a physical machine. You have to slide it into the network rack. You have to make sure you've got the right amount of memory in it. So you're probably putting the memory in, you're configuring the disk drives, loading the operating system, turning it on, etc. Whereas with the virtual machine, if you want a new virtual machine, well, I copy that file to that file, bang, up it spins. Who doesn't believe me how quickly virtual machines can be provisioned? I'm going to show you that in a second. What was that? 4 of 9. Okay, so we've got one more question. Max still at the top there. Well done. We're all cracking along. Last one in this section. Select all the tools that can, should use for optimizing our virtualizations. Yep, it's the lot basically in there. If you ticked all of those, you are totally right. Remember, our hypervisor monitor is going to monitor how our hypervisors are performing. The resource allocation is basically going to check that we've balanced it right. Okay, so we've got the right virtual machines running in the same box with the right virtual machines, so it is nicely allocated. Performance monitoring tools are going to monitor how our systems are behaving, and load testing tools allows us to smash everything in there. So basically see that when our server is put under the strain that we expect it to be put under when it goes live, that it will perform perfectly okay. Withersham, well done, banging it up to the top. Okay, any questions around that area? Partially correct. You get some points, some virtual suites for being partially correct, obviously. So let's have a quick glance at the platforms that we can have. There are a lot of virtualization platforms out there. VMware and vSphere are certainly a very popular one. VMware is basically the hypervisor. vSphere tends to manage the hypervisor. So if you've got several hypervisors, say for example you've got 8 machines and you're running several different hypervisors, vSphere is the one that will get those all together and it'll help you allocate and swap ones around. Allows you to do active migrations, hot migrations and things like that. Microsoft has a product called Hyper-V, which is very nice. I'm not getting paid at all by Microsoft to say that, but it is very nice. I'll tell you an embarrassing story, actually. Yeah, go on, we've got a little time for a story. Embarrassing story. I went for an interview at Microsoft. I worked at Microsoft years ago, and then I kind of thought, oh, I'll possibly go back there as a technical account manager. So I went for an interview there. They laid out a particular position. They said, oh, Dave, we want you to, do this presentation, write this presentation about virtualization and stuff like that. And I went through all the presentation. Fantastic. They loved it. They thought it was really good. And then the guy basically leading the interview leaned over to me and he said, we noticed on your presentation that you recommended a hypervisor and you recommended VMware. Why didn't you recommend Microsoft's Hyper-V hypervisor? And I just looked at him and I said, well, to be honest with you, VMware is better than Hyper-V. I didn't get the job. Never mind. And of course, we know full well there's all our cloud-based virtualizations. Now, we don't have to think so much about those, but we can spin up different virtual machines. So someone else is handling the hypervisor end of it. We don't have to worry about that. We just go, we want this machine, bang an operating system on it, and then the cloud-based system works for us. So VMware and vSphere, we've said, is basically a great virtualization platform. It throws in the ESXi hypervisor, which remember is the one that runs on the physical hardware and does not require an operating system to run on. It is very nice. Don't tell Microsoft I said so. Hyper-V is integrated with Windows Server. If you put Windows Server onto your machine, 2025 or earlier, I think they started doing it with 2012, you will get a certain amount of virtual machines you can run. Okay, that's all part of that purchasing that server system. And depending if you buy standard, pro, or data, would depend on the number of licenses you hold to run virtual machines on those systems. So they are pretty nice systems. And there's the cloud virtualization that we talked about. Okay, this is where we don't have to worry about our hypervisor, isn't it? Okay, it's highly available, fault tolerance, because I'm not having to worry about what is going on underlying in the hardware. We talked about PaaS, SaaS, and IaaS, infrastructure as a service. If I'm going to a cloud hypervisor provider, essentially Azure, Google Cloud, or many of the others that are out there nowadays, I don't have to worry about, that hardware. I don't have to worry about where that data center is. I know full well if I get in the right zones and the right regions, they will simply spread it all about. And if they have a big fire in one location, well, I don't care because it's simply be hopped onto another automatically for it. So it takes a lot of the worry about, and we can basically utilize virtualization really easy off those. So you kind of get those three and you kind of ask yourself, which virtualization is right? I see Seth's got a question there, but I can see someone's picked it up. That's good. If we haven't answered that one, we'll come back to that one. Here are some key considerations. Yes, there's AWS for cloud servers in there. We did miss that one out. We didn't do it deliberately, just to annoy them. So here are some key concepts. So hypervisor, host OS support. So you've got to think about what operating systems that hypervisor might basically support and whether or not you do go for a hypervisor enabled operating system on there. So it is aware. Remember I showed those different types at the start. Guest operating support. Think about how you're going to manage to support your guest operating system. It's great saying I can have lots of different virtual machines, but if I'm, for example, running our beautiful Linux systems, I need support for Linux. I need support for that Linux box if I'm basically running it, just as I would if I put it on the straight hardware itself. So you've got to think about the guest OS support and how it basically will manage that. Hardware compatibility is not normally things we need to worry about. If we're talking about a hypervisor, but it's things we should be aware of. Some processors, it's all swings and roundabouts nowadays, isn't it? Some processors are better with a particular hypervisor. Okay, if you need to get into that much details, then probably I suggest you get up in the morning and do something else. But yes, because they are different, because we know the Intel processor is different from the ARM, the AMD processor. And indeed, there are other processors now that are coming out, which is more big thinking for AI integrated things and different hypervisors in there. It's important we kind of have a little bit of thought about our hardware compatibility. Scaling up and needs, that's really only really relevant if we're doing it ourselves. So if we do have 3 or 4 servers, then we need to think about what hypervisors and what systems we're running on and how we're going to scale in the future. Now, 3 systems might be okay. 256 gigs of RAM might be okay. A couple of terabytes of storage might be all right. So we need to basically think about expanding on that. Will that be okay in a couple of years' time? And there's some high availability features. We talked about vSphere basically being able to shuffle systems across and then basically move those virtual machines from host to host without any downtime. There are others out there that will do the same sort of thing. And we've got to think about the tools that we're basically going to use to support those particular items. Never forget security. Please never forget security. And we've got to consider, do we do on-premises versus cloud deployment? There's a good question for the chat. Do I need to decide to do all on-premises or all cloud deployment when I'm talking about virtualization? So a yes or a no in the live chat. Do I need to go all in one or the other, or can I basically have a different one? Cablan's gone no. Paul's gone no, not at all. Yes, because we know full well, that's some of the other answers. Because we know a lot of companies, why would I want to shift? If I've got a load of on-premises servers that I can now basically run virtual machines on, well, I'm going to keep doing that. If I need to expand, do I want to go to the cloud? Well, I have that option. I have the option to mix and match for both, so I can do both systems. And there's a bonus bucket of sweets for whoever can tell me what that type is, where I'm mixing on-premises with cloud environments. Hybrid. Oh, bucket of sweets coming your way. Well done. Yes, it's a hybrid environment. Lots of companies are doing it. And why wouldn't you? Was just a great guess, Paul. Don't say that. Never admit it's a guess. So connecting to virtual machines. Hold on, we did something the other week, didn't we? Connecting to virtual machines. How do we connect to machines? We know we can use SSH, which is our secure shell. Yes. Just because it's a virtual machine, not a physical machine, we can still connect in exactly the same way. So we can use SSH. We can use a terminal access if we want. So we can use the terminal command, the virtual machine lines. And we can use our remote desktop system, basically to connect to all our systems. Now, if you're running something like Oracle Box, yes, you can very simply do it across Oracle Box as well. We've got 58. Okay, we're good. Just thinking now, all I was thinking. I do a lot of it, sorry about that. I remember the other week we basically talked about RDPing across. Okay, so that's my virtual machine just running on my virtual environment, just as I would do for a physical machine. I should be able to remote desktop across to that system. I know which Windows is going to pop up, and it never works always the same when I try to do it. So that's the IP address of that particular machine that is running. I'm going to connect to it. Hey, oh, I went to the right place. More choices, use a different account. David, that's the one it's currently logged on with at the moment. I'm going to get a warning, basically, because it recognizes it might not be kosher. And you see what happens when I basically connect across to this? It logs the user off. That's because I'm logging onto a PC and not onto the server. Somewhere in the background on one of my screens, I'm now going to get another machine pop up. Possibly. It may just be taking its time. Perhaps I type the password wrong. So you can see basically we can connect across with the RDP sessions as you. I'm going to let that connect across while we drop onto the next slide. So a reiteration from the other week, literally, RDP versus SSH. RDP is most suitable when you want to look at certain VMs that are in the Windows environment. We get the graphical user interface that we can see. SSH is much more text-based, a lot slicker, a lot faster, great for scripting. RDP is more bandwidth intensive because we're transferring the graphics across the system. So graphics are big and chunky. RDP potentially, I always like to say the word potentially here, is more vulnerable to security breaches than SSH. It is not as robust as SSH. It is more user-friendly. If we're doing tweaks and manual configurations, yes, then it's a lot better than SSH because we do have a bit more graphical control over things, which is potentially what we're used to. So we've already spoken about utilities of remote desktop. It is installed on most systems. On Pro systems, it will be. If you're basically running a home system, then you won't have RDP as a connection option. One thing definitely to remember is most system firewalls, when you install Windows or when you install most of the operating systems, these remote connections tend to be blocked. Windows Firewall says, I'm not going to allow anyone to RDP to the system unless you open it up. So you've got to open up the firewalls and allow the rules basically to allow the remote desktop connection across. So you have to make a few changes on the client/host machine. Big things to basically do is make sure you set a strong security password on these things. Most servers that you're working with, if you're in an environment, will be controlled by something like Active Directory, users and computers. Okay, which will basically then mean you have certain administrators, you have people that are allocated the administration task rather than an administrative logon. So you should never log on to a server as administrator. You should always log on to a server of yourself. And that, of course, allows us to manage and look at what is basically being done, because we can have a look through the protocols and things like that to see who has logged on when and what actions they basically performed. I don't know who's used SSH. I always use Putty to run my SSH. Has anyone else got any different opinions as to what they use? If you've done it before. Please smash it in the chat window if you use one regularly. It's a choice thing. There are lots of different tools that basically will allow you to do SSH connections, and a lot of it depends on simply which one you prefer. And it's as simple as that. And you can see in here, very similar to what we did with RDP, we're giving it an IP address or a name, and we're asking it to connect through. We kind of did a bit of that the other week, didn't we? So who's ready for a little bit of Kahoot then? We've got a last little section for Kahoot. I think it's the last one, might be a bit more. 9, I think was the lot. Let me just grab that section. Couldn't connect, so I typed the password wrong. Get wrong my magic virtual box. Juggling a few windows here, people. Okay. Right, ready for Kahoot then, people? Which virtualization platform would you use for Windows platform? So which Hyper-V would you use? Oh, which Hyper-V would you use? I'm going to go and sit in the back of the class for that one. Which hypervisor would you use? Microsoft Hyper-V. Good. Well done, everyone who got that answer right. It is basically installed with the operating system. Max jumping up. Paul B. Arise as well. Ablan, big streak from you. What is the preferred connection protocol when using a Windows machine? SSH, RDP. We tend to prefer Cablan's and SSH personally. Windows machines tend to use RDP. Yes, you can use SSH. There's nothing that stops you from SSHing onto a Windows machine. Nothing that stops you using RDP onto a Linux machine. But let's see what the next question is. Gabino, Sebastian, basically jumping up there. Good work. True or false? Is SSH used to connect to Linux machines? That number whipped up really well. The answer's basically whipped up there. Let's see who makes a big dent in the fastest fingers first round. There you go. So generally, we would use SSH basically to connect to Linux machines. We do it for the Mac as well. And we do tend to use it because it is a scripting language. So we tend to do an awful lot of big, powerful stuff with Linux boxes. They tend to be a lot of the web servers and things that we see out there. And it's very nice and easy to connect through and basically change web pages and things by running SSH scripts. Max jumping to the top. Mardi, Zachariah up. Well done. Up 3 places from Precious, the highest climber. Okay, so last question of today. True or false? We can use RDP to connect to a Linux machine. Get this one right, Kaplan. Split, you see. We can use RDP to connect to a Linux machine. It's an option. We can basically do it. It's nothing that says we can't. We do get the full feature-rich environment in terms of it becomes a graphical environment that we transfer across. Yeah, but most Linux machines, you will have to install an RDP client on them. It won't come native with the box, depending on the flavor of Linux that you've got. Remember, because Linux is so customizable. Yes, you can certainly connect RDP to a Linux machine. Cool, let's see how that ends with our virtual podium. Who's getting the bucket of sweets today? Mardi, well done. 3rd place. It's good to see you up there. Max, beautiful work. Who takes the biscuits today? Paul B, well done. Cabino, Zachariah still in there. Well done for everyone who took part in that. Let's just finish off the last couple of pieces then today. So desktop virtualization, you've seen me do a bit, but there's also some other formats for virtualization. They kind of throw this on. Installing Windows on a Linux computer, dual boot setups. We can do all these things. We have the option on our system, when we basically do some installations, when we basically configure things, we can enable a dual boot system. So my individual machine, my one machine, I have the option to run separate disk partitions on there. And one disk partition can boot up Windows, and one disk partition can boot up Linux. I won't do it at the same time, though. That's the important thing. When you boot it up, I can select, it will give me an option, press 1 to run Windows, press 2 to run Linux, and it will simply pop into each one of them. So they are installed differently. Okay, and they tend to be configured with a bootloader, such as Grub was a good example in there. Okay, where you basically ask to choose an OS at the time. And the difference between that and a virtual machine is we are not running in a virtual environment. There's no Hyper-V that gets involved there. It is very simply you boot up and then the operating system loads on top of your hardware, whether or not you choose 1 for Linux or 2 for Windows, it simply loads that up. That just gives you other options, I think is what we're throwing on here. And virtual machines, yeah, there's no reason I can't run applications. Remember the virtual machines, virtual machine applications. For me, it's better Linux without Windows. Well done, Gigabits. So virtual machines, yes, I run VirtualBox. There's the only one out there, as you can see. So KVM on Linux, where we can simply spin up a virtual environment. I demonstrated there a couple of virtual machines that we were running. And quite how easy it was basically to do it. So we can simply run it. We don't need a server to run it, but we do need a hypervisor to run any virtual machines. So when you compare the two, dual boot basically means you run on the native hardware. So there's no hypervisor in between. You get the most efficient use of all that memory. You run on a virtual machine, you remember your hypervisor and the application, that's still going to basically be taking up resources from your system that are then potentially going to slow you down. Not massively, but it's always worth considering. So there's obviously a few options in terms of running Linux on a Windows computer. Windows now has a subsystem for Linux, a WSL. Okay, WSL allows native Linux command lines with Windows. Okay, so you can run Linux binaries and run directly on the Windows kernel. Simple to install Linux from distribution stores and other items like that. We can run it as a virtual machine. To say we can do it as a dual boot. Installing Linux on a Mac? Who would dare do a thing? We know the Apple operating system is a Linux derivative anyway. Remember, it span off years and years ago. But yes, you can run Linux on a Mac. I run it upstairs in my bedroom at the moment. I run a Mint on there. I think I mentioned that probably when we went through the Linux environment. And if your Mac is getting a bit tired and old, and it won't run any of the updates and won't basically allow you to update the operating system, well, it's no good just using it as a doorstop. Why don't you just stick a Linux operating system on it? Then you can run the latest security patches. You can keep yourself safe and secure and still carry on doing things with that system. Kavitsu says it took 2 days to find a compatible WSL. Yeah, sometimes it can. Good bit of research on the internet will probably help you there. But well done. I'm very impressed with you running that. Well done. And we know, of course, we can revert to our good old virtual machines. Yeah, we don't have to think too much about these things. VirtualBox, VMware Fusion, I think is one up there as well that's mentioned. You can run those on Mac. Okay, and you can basically stick Linux onto those as a virtual machine and do what you fancy with it. So as a bit of a summary then, we know virtualization basically offers an awful lot of flexibility for us. Okay, it saves us cost. Remember, cost, very important for us because we don't need to replace hardware. We can simply stick new virtual machines onto this existing hardware. and we can optimize that power by sharing the resources. I'm not buying extra memory, I'm simply sharing that memory amongst different virtual machines. It gives us the flexibility. We know we can simply take a virtual machine and we can drag it, we can drop it, we can copy it around our virtual environment. So although I'm running 5 or 6 physical machines, I can move the virtual environment, the virtual machine, from one machine to the other. I can duplicate it across them all. So that if one machine falls over totally, I'm still running that virtual machine on the others and still making things available. It gives us a bit more agility because they are so fast to spin up. They are so fast to copy. And they are so fast to basically create. So it does give us that particular environment there. So as a bit of a conclusion then, we've spoken about the concepts and the advantages of virtualization. We've spoken about some of the challenges that you remember. Some of the issues we can have is with security. You've got to make sure everything's patched. And indeed, that's where we rely on our monitoring tools to make sure that we're up to date. Spoke about a little bit of the configuration and other items along those sort of lines, where we talked about the virtualization platform and their applications you can use. So I think we've probably given you a really good broad background there for virtualization. So I've got any questions or anything they'd like to ask? We're all pretty good, I guess, aren't we?